Hello, this is Sandra Leong from HP. Thank you for joining us today for our analyst briefing. I'm really excited to have you on the phone today to hear about an announcement that we're making on November 1st that we think will be a significant one with great impact on the server market as we know it today. I have on the phone with me today Glenn Keels, Director of Marketing, ISS Hyperscale Business Unit, along with Gerald Klein, the Head of Platform R&D for ISS Hyperscale Business Unit as well. Together, Glenn and Gerald will take you through the announcement material and will highlight the announcement elements deck. Please note again that the embargo date is November 1st, and at this point in time, I'm going to go ahead and turn it over to Glenn.
Thanks, Sandy. So wherever you are in the world, good morning, good afternoon, or good evening. This is really, really exciting news. On November 1st, we will be unveiling a multi-year, multi-phase project that we have dubbed Project Moonshot. A little bit of background before I get into it. About a year ago, we began working on a very secret project developing an ARM server. And over the past year, we have learned by talking to customers and by talking with our partners that we need to do much more than just release an ARM server. We need to make sure that the industry is ready for it, that we're giving a guided path to customers, that we're rallying ecosystem partners to unlock the promise of what we're calling a new category of servers, extreme low energy servers. That is whether it's ARM or Atom or other processors and server architectures born in phones. So Gerald and I are going to tag team this presentation. We're going to first set the stage for the problems that we're solving. Then we'll tee off on exactly what we're announcing, go into detail on the 4 points that we're announcing, and then wrap it up with how this will unfold over time and why we believe HP is not only positioned to lead but has an obligation to lead this key market inflection point. So let's begin. To form the context, we all know on the left-hand side of this slide talks about our new connected society, our new connected era, where every second of every day we have more and more content, collaboration being uploaded to the internet. More and more users every day are being connected for the first time, connected to their friends, connected to their colleagues, downloading and viewing content. Thousands of pictures every second of every day are uploaded and viewed. Hundreds of thousands of texts, hundreds of thousands of Twitters or tweets are being sent across the wire every second of every day. More than 2 million videos are being viewed and uploaded every single day. I myself am being trained by my children to how to use Facebook and how to use Twitter and how to use the web in ways that we never thought of just 5 or 6 years ago. Great new business models are being created. Innovation that actually changes our lives worldwide is happening on the demand side of things. Most people don't realize, though, on the supply side of things, there are the unsung heroes of the data centers that actually power this new connected economy. And every day, to keep up with that incessant demand of connectedness, more and more servers occupying more and more space and eating up more and more power is being added to an already overburdened infrastructure. By 2015, this dynamic will have reached an inflection point we haven't seen in the technology industry to date, with more than 98 billion mobile applications being downloaded to more than half of the connected worldwide citizenry, the majority of which are connected via mobile devices. Even today, if you were to stack up all of the servers that are serving this connected era, just the power that they consume equals between 1.5 to 2.5 points of the entire United States energy bill, and in fact could power Las Vegas for more than 6 months. And that is just that burden is just going to get heavier and heavier on the data centers that serve this connected economy. We at HP have been proud to be serving these types of customers over the past few years, really beginning in the 2005, 2006 timeframe, when we started to see these Web 2.0 Goliaths emerging that had a different business model. Instead of IT being a part of or a cost of doing business, IT is their business. IT is COGS on their income statement, not an expense below the line. They demand a different form of technology. They demand purpose-built infrastructure that is delivered at a velocity that we haven't seen in the technology industry today. And they have higher demands on quality in both terms of quality of product as well as quality and precision of execution of delivery and support. Over the past few years, we have moved at HP from building custom servers for these types of customers that are specifically designed for their applications and deployed in the tens of thousands in, let's say, the 2006 and 2007 timeframe, to container data centers. We've morphed and provided additional value, taking that same purpose-built approach but applying a common modular architecture with our current Proliant SL platform that brings that purpose-built essence to servers, but also delivers increased flexibility and increased power efficiency as well. In fact, today the SL 6500 is the most power efficient server, two-socket mainstream server in the industry. We've taken that same approach from moving from containerized data centers to truly modular data centers over time. With our latest announcement with the EcoPod in June of this year, where we're driving a PUE of down to 1.05, darn near perfect power usage effectiveness. We will continue to be continuing to improve on power efficiency in our traditional x86 scale-out infrastructure and modular data centers to get even better power efficiency, to get even better performance and price performance per watt. But as we look out to that year 2015, over the next 4 to 5 years, taking just incremental steps simply isn't enough. We can continue to get, let's say, power usage effectiveness from 1.05 to 1.04. We can move powertrain efficiency from 92 and 94%, getting an additional percentage point of efficiency out of it. But while you can count on us to do that, data center expansion and the crisis that some of these customers are in from a capacity, cost, and complexity standpoint needs new thinking. In fact, between now and 2014, new data center expansion or new data center build-outs are expected to double to be able to handle this increase in user demands, user connectivity, content, and collaboration. So we need to think beyond just incremental steps to handle this crisis of capacity. We need to think how can we create some quantum leaps in efficiency, in scale, and in cost. And we do have those opportunities, and that's what we'll be talking about today, is what's next besides traditional x86 scale-out architectures. We do see, as we move into what's next, that there is tremendous promise. As HP Labs has looked at what has been known as alternative processors, we're coining the term extreme low energy servers over the past few years. We believe that these have enormous potential. These processors, systems on chips that were born and bred for ultra power efficiency, usually found in mobile phones and embedded devices, do have enormous promise from a space and energy and overall cost standpoint. They deliver a fraction of the power at full utilization and almost non-existent power at idle. They're designed for density and size, and they're also designed for very low cost points, allowing us to provide potentially a much greater density within a smaller power footprint and at a lower cost. There's been a lot of speculation around this new category of extreme low energy servers. Again, whether it's ARM and all of its derivatives, whether it's Atom as well as others. There's been a lot of market hype, and there's been a lot of skepticism, frankly. We believe there is promise, but we believe it takes an industry leader to be more pragmatic, unite the industry to unlock the benefits of these extreme low energy servers. Where do they count or where do they make sense is part of the first discussion. Based on our experience in HP labs and based on the performance projections of various technologies in traditional x86 servers as well as extreme low energy servers conducted by Gerald and his team and his lab, we're seeing the market sweet spot from a suitability standpoint really in the large web, social media, and hosting companies that have a business model of deploying at a significant scale in the thousands of servers at a time, that also are serving up 1, 2, 3, 4 applications to millions as opposed to hundreds of enterprise-class applications to a smaller number, and also are fairly sophisticated with their application developers. Based on the performance that we are forecasting and the business model that those types of companies currently have, we believe that that's the sweet spot. It's not to say that there isn't some suitability in more of the compute-intensive, advanced scientific and technical computing and high-performance computing, and in some cases, mainstream IT might find some use, but the real sweet spot based on business model and our performance projections that are weighted and forward-looking are really around these types of customers. We do believe that in these types of customers that are serving up this connected economy, this connected society, that by 2015, it's very possible that this new category of servers could grow to more than 10 to 15% of the global server market worldwide. So it is material. There is opportunity here. However, there are adoption considerations and barriers, in fact, to make that a reality. The three major adoption considerations that we believe need to be addressed are, first, application selection. So not all applications will receive or are suitable to get the space, cost, and power savings, just due to the application characteristics. We'll go through that in a little bit, where those specific applications are. But customers need the ability to take their applications and test and investigate and benchmark, in some cases port and tune their applications on this new type of server in order to really get the benefits. There's also the availability of software from the ISV ecosystem that's a concern that we believe can be solved over time but must be addressed. The second, and equally if not more important, is the proliferation of infrastructure. Every time you add a server in today's traditional scale-out model, typically you will add the corresponding number of devices and instances, management endpoints that need to be procured, powered, secured, managed, cooled, etc. And as we move from, let's say, 100 traditional x86 servers performing an amount of work of X to these new extreme low energy servers that you might need 5 or 10 of those servers to perform the same amount of work, we need to make sure that the increase in the server count does not also create an increase in device proliferation that could offset. The cost of that could actually offset any savings a customer could receive in space, power, and cost based on the servers itself by additional operational costs, by additional switching, networking, etc. The third key adoption consideration or barrier that we've seen that needs to be addressed is risk reduction. These customers, as I mentioned before, IT is their business. Most of the companies, whether they're silicon providers, whether they're software providers, or whether they're systems providers, are fairly new to this game. They're startups. And these types of customers absolutely need the breadth of capability, the history of leadership, an innovative roadmap that's long-lasting, solid worldwide support, cost containment on their infrastructure, and continuity of supply if they're going to bet their business on it. So the customers are really saying, hey, we need industry leaders to unite around this and go hand in hand with some of these startups to make sure that, in fact, we're not, to use a phrase from the 80s, buying a Betamax here. So with those adoption considerations and barriers to adoption, if we're really going to unlock the promise here, we've moved well beyond just introducing an ARM server, okay, and are introducing on November 1st a multi-year, multi-phase project designed specifically to unlock the power of these extreme low energy processors. At its core is an architecture that will be enabled over time, that is federated, that decouples scale from complexity, that every time you add a server, you don't have to add a corresponding number of devices that have to be powered, cooled, secured, managed, etc. To enable that architecture over time, there are, let's consider them, 3 lanes of a highway on this destination. The first is the HP Redstone development platform, an incredibly flexible, incredibly power efficient server specifically designed for development. It is an ARM-based server, and this is the first of many to come, both development platforms and production platforms that will begin to incorporate extreme low energy server processors and SoCs. That will be made available in the first half of 2012 in limited quantities to select customers, for customers to begin investigating application suitability, testing, benchmarking, in some cases porting and tuning prior to production deployment. For those customers that prefer to collaborate and not have the development platform on site, we're also introducing the HP Discovery Lab, specifically designed to enable customers to navigate this journey ultimately to a more efficient environment for those applications in the Moonshot architecture, where they will have access to the Redstone development platform, other development platforms, as well as traditional x86 environments, to confidently and with unfettered access to technology begin testing and benchmarking their applications to determine the suitability and full production deployment if the suitability holds true. There they'll be able to, again, have access to the technology, but also have access to HP experts, some of which are on Gerald Klein's team, HP Labs experts, and equally important, peers, industry peers of theirs, and industry experts from our Pathfinder program members, which we'll get into in just a second. The third leg of the highway, probably equally as important as any of these, is the Pathfinder program, specifically designed to begin uniting the industry with ecosystem partners ranging from silicon partners to systems and infrastructure partners, with special emphasis on OS partners and ISVs to enable the software ecosystem. These software partners will be contributing their capital, whether it's technology in the form of systems or capital in the forms of software, as well as capital in the forms of their intellectual knowledge and technology expertise, specifically designed to help customers along this journey to the Moonshot architecture and these new category of servers. In addition, these partners will help to lead work groups of customers with HP to develop usage models, to publish best practices, and create both ad hoc industry standards as well as formal industry standards to enable the Moonshot architecture over time. So again, specifically designed to unlock the power of these extreme low energy servers, multi-year, multi-phase, a vision in fact. The end result is the HP Project Moonshot architecture and 3 legs that will be built over time, the Redstone development platform, the Discovery Lab, and lastly but not least, the Pathfinder program. Let's real quick go into the architecture and the principles of the architecture, and then I'm going to hand it over to Gerald, who can get much more in depth on the architecture and the development platform itself. So the Moonshot architecture strategy is quite simple, is to move from tens of servers per rack in a traditional x86 scale-out environment, basically sharing nothing, to thousands of servers per rack sharing everything, where the server itself in a traditional x86 architecture is largely built around the CPU and memory complex itself, as opposed to a vision of an architecture where we have more of a processor-neutral infrastructure where the CPU and memory complex is designed to fit into a shared federated architecture that seamlessly scales as you add nodes or servers, as opposed to having complexity increase with every server added. That's the basic core and the destination of the architecture. I'm going to turn it over to Gerald now, who will go through more of the attributes of the architecture, as well as the Redstone development platform that begins to deliver against the HP Moonshot architectural strategy. Gerald?
Thanks, Glenn. So on this slide, what we're showing is the future architecture, and it's really an extension of our existing SL common modular architecture, which shares power and cooling today, but there are other key attributes that we're going to start sharing across the system. So as you look at this slide on the left-hand side, you see a graphical representation of traditional x86 scale-out. Each of those would be a one-use system with its own processor, chipset management, storage, cooling, and power, and NIC associated with it. Whereas on the right-hand side, you see the Project Moonshot architecture, where the processor and chipset are still individualized and their own physical instance with a physical OS on them. The chipset's then pulled into the processor, into a system on a chip, inside of these extreme low energy processors. But then everything else below the processor becomes a shared component of the system. The way we do that is we've pulled out items like ILO and pulled it back down into the chassis. We've pulled out items like Smart Array and pulled it down into the chassis and the enclosure. And then we federate those at a rack or row level to be able to manage them much more simply than you would in the past. So as customers scale out their platform or scale out several hundreds or thousands of platforms in their data center deployment, they can manage them more simply, utilize them more simply, and share things that they couldn't before, which allows us to save energy and cost. So as we go through it, the processor and chipset are based on an agnostic architecture. So we have a vision where different types of processor architectures can fit into the platform, both x86 or ARM, or even in the future, some accelerator type platforms could go fit into the architecture. Below that sits a management framework, which is pulled back into the chassis, but then acts as if it's a brother right next to the chassis that's adjacent and adjacent to him, and we call that federation, where you manage it at a rack or row level, and it's self-aware, and it builds out an architecture that you interface with using either a single IP address or a single management interface. We still support industry standards to get all the way down into a node for power on-off, for example, but you also have the choice to do things like update the ROM through a single management interface as opposed to going to every individual node. So we're really trying to simplify the sprawl and scale that comes with managing several thousands of systems at once. From a fabric perspective, it's very important that we start to share the fabric inside the system and integrate the fabric into the system, especially as SoCs come on board that are much lower power, and the performance of an SoC you may need to replace 4 SoCs with a traditional dual socket platform. That's 4 network connections to manage. So we've needed to share that to solve the problem of sprawl there. And then it also reduces the cabling and some of the costs associated with extensive fabric networks coming outside the chassis. At the same time, that same fabric management plane is hooked back into our hyperscale ILO management plane and federated with that as well. Very similar to what you might see in a stacked switch, where you manage it as one row or rack level as these things are connected and scaled out. Below that is shared storage, and that's the next attribute. You may consider shared storage something like a SAN or something external to the box that's ultra redundant. What we've tried to do that's a little bit different here is really go after the cost of a SATA cable and a very low-end SATA drive. And so we started with that as the foundation and created an architecture within each chassis or enclosure where we can share across multiple nodes a pooled set of storage. And we're basing that on our Smart Array foundations and our Smart Array firmware, which gives us a lot of flexibility to go and slice drives up on a per node basis, where we can share one drive across many nodes or a couple drives together to share them against one node. So we've got a pretty robust offering there. For cooling and power, we're already doing this today in our SL and EL product lines. So it'll be very much analogous to the way we're sharing fans and power supplies there. However, we do have a very robust roadmap for both cooling and power for the future, even at a rack level, that we're going to incorporate into the future architecture. So these are the attributes that piece together our vision for the future of Moonshot. We've developed a platform called Redstone that Glenn mentioned that pulls together some of these key attributes, specifically the processor and chipset and SoCs, shared fabric, and shared cooling and power. And we'll go through that in a minute. And once we pulled all that together and looked at the performance at the same time, we were able to model up some pretty compelling quants when you look at traditional 86, x86 dual socket system as compared with the HP Redstone development platform for the workloads where we really see this as taking off. So over on the left-hand side, we've modeled up 400 server deployment of traditional x86 dual socket 1U pizza boxes, which would take up about 10 racks, 20 switches, 600 cables, and produce about 91 kilowatts of energy. Over on the right-hand side, using a 4-to-1 ratio of the Redstone-based nodes to the x86-based nodes on the left, which we'll go through the performance in a minute, we were able to model up about half a rack worth of this equipment, which saves about 94% of the space, only 2 switches as opposed to 20, 41 cables as opposed to 1,600, and 9.9 kilowatts. So that the energy savings alone is tremendous for the right kind of workload. So the workloads that we're primarily targeting are what we call light scale out. So simple content delivery. These would be static web servers with little processing local to the system where you don't necessarily need a Bronny core, or video servers that are simply fetching the data and forwarding it along to an end user unmodified. In addition, large distributed memory caching servers. So Memcache, part of the web front end stack, we see as this server playing very well there. In addition, big data oriented search systems like Hadoop. All three of these, we've run performance benchmarks in our labs, and we see some pretty awesome results even on the hardware that we have today. And we see future hardware coming that is even more compelling. So we believe that for these particular application workloads, we can provide some very interesting savings. For mainstream workloads, we don't see the same kind of cost savings. For a lot of these workloads, you need to increase the quantity of nodes to see the same amount of compute. But there are some cases where we see some power and safe savings. So on the fringe of some mainstream customers who are power or space constrained, there may be some interesting applications here, but we don't really see a lot of play in that space. And then for compute-intensive workloads like floating point, we don't really see the Redstone architecture playing right now. We do see potentially in the future some interesting things out on the roadmaps with some of the SoC providers, but at this time we don't see a lot of play there. So for the Redstone platform, here's a picture of it on the left. And so on the left, what you see is the SL6500S chassis, which can contain 4 trays in a single 4U chassis. And in this case, we chose a 2U half-width tray. And so in middle of the screen, you can see a 2U half-width tray filled with Redstone nodes. It's up to 72 servers in the equivalent of 1U. So it's 2U half-width, which in a full-width version would be 1U tray. The 6500 scalable system has pooled power and pooled cooling with 4 common slot power supplies and 8 shared fans. Inside the base of each one of these 2U trays is an integrated configurable network fabric that's based on the SoC that we've chosen here, and then each has 4 10-gig uplinks coming out of the system. And so inside of a 4U chassis, you can fit up to 288 servers. There are 18 quad-node compute cartridges per server tray, so each one of these nodes has 4 SoCs and 4 independent servers. It's based on the Calxeda Energy Core, and we'll go into that in more detail on the next slide. And each of those can have up to 4 gig ECC. That's per node. There's integrated management for rudimentary IPMI commands. The Redstone development platform doesn't have some of the federated management that we planned for the Moonshot architecture. You'll see that later on, and Glenn will show you some of the roadmap slides for that. Its storage is shared and configurable. Over on the left-hand side, you can do a diskless version that has up to 72 nodes per tray. Each one of those nodes could have a micro SD card, so there is some local storage you could do on each of those. In order to use disks along with the nodes or SSDs, you need to remove some quantity of node cartridges, and so there's a trade-off there. But you can get up to 192 SSDs or 96 2.5-inch small form factor hard drives per enclosure. So the architecture for Redstone really spans different applications, from web front end with the simple node with no attached storage, all the way to some Hadoop implementations where you may have up to 4 drives attached. So each of the compute cartridges, as you can see in the middle here, has 4 independent Calxeda Energy Core SoCs, and then 4 mini-DIMM connectors, and then direct attach SATA ports to support the storage. What's interesting about Calxeda, and the reason that we've been working with Calxeda, is that they've really built the SoC from the grounds up to be an enterprise-ready product. They have quad-core ARM. They have management built in, a fabric built in. They've got an increase the L2 cache to be more robust with respect to enterprise and in particular hyperscale workloads. But they're still based on the ARM core efficiency. So ARM emerged in mobile devices and tablet devices where they track microwatts. And so it's a different mindset when you're designing a processor for Moore's Law, where you're trying to get the most you can out of silicon, versus for battery life consumption. So the total power of each individual node is roughly 5 watts under utilization in these kinds of workloads, and its idle power gets all the way down below half a watt, and it's dynamic in between. So depending on the utilization of the application, we expect this is how some of the energy savings come forth. And you can see a comparison in the middle based on a single CPU with 12 gig of DDR versus 3 SoCs. Under a regular workload, we expect to see huge power savings. In addition, they have the integrated systems management and high-performance fabric. So the fabric actually runs up to 10 gig per link, and it's dynamic in the way that it spans bandwidth all the way down below a gigabit to save power. And then it's a very simple approach to computing. So it's standard drivers, standard interfaces, standard IPMI interface for the management. So no real surprises there. But it still is based on ARM, and there is an ecosystem change that needs to occur. And so Glenn is going to talk to you about the Discovery Lab and how we plan to handle that.
Yeah, so thanks, Gerald. Again, At the core of the Moonshot project is the architecture, and the Redstone platform is HP's first platform that incorporates extreme low energy processors and is specifically designed to be flexible, energy efficient across a variety of those targeted workloads for customers to start their experimentation, their benchmarking, and so on. And it'll be available to certain customers. By the way, that's a picture of Gerald there, in case you want to know what he looked like. It'll be available to select customers in limited quantities in the first half of 2012. Some customers, though, either because of access or because of funds, will still want to have access to the Redstone platform, other platforms coming from HP with extreme low energy servers, or at the same time, traditional x86 environments to benchmark their applications to determine that application suitability in the architecture that's going to fit best. And that's why we've created the HP Discovery Lab. This is the industry's first lab that's specifically designed to help customers navigate this journey to extreme low energy processors, extreme low energy servers, as well as to have customers hand in hand with industry leaders to determine how do we deliver best practices, usage models, and standards to develop that Moonshot architecture over time. It'll be a first on-site facility in Houston that's also accessible worldwide remotely, where systems can be checked out in a cloud model. Results can be kept confidential or also can be shared with partners and peers. Expertise will be provided by HP Labs experts and distinguished technologists, as well as Gerald and his team, as well as our partners that are signing up in the Pathfinder program. Over time, we'll be expanding our physical labs from not just being in Houston, but also to be in Europe as well as China. We'll be opening it up officially in January, and again, I think it's a fantastic tool that's very complementary to the first development platform, Redstone, to help customers have a guided tour along this journey, and to not only learn themselves, but to instruct industry leaders on exactly what they need, what works, so that innovation can be productized. So that's the Discovery Lab. Equally, if not more important than the other two, the platform itself, the Discovery Lab, is our HP Pathfinder program. And this Pathfinder program is the beginning of a consortium of industry leaders, both large and small, that are committed to providing customers the technology, the know-how, the best practices to be able to navigate this transition, as well as to develop standards and best practices and publish those as the Moonshot architecture develops over time. We've been quite selective and quiet, just to preserve the integrity of the announcement so far. So the list is of partners participating is intentionally small. We'll be adding quickly to that with both silicon partners as well as systems partners, and especially OS and ISV partners, as applications and application suitability and software availability is one of the key adoption considerations for these technologies. Again, these partners will be contributing their capital, their whether that be products in the form of systems or software, their expertise in the form of their experts to help customers test and benchmark and so on. And then also Pathfinder partners will be leading work groups with customers and partners alike to develop best practices and standards and tools to enable that Moonshot architecture. We liken this to what HP did with blades a few years back, where Blades was somewhat of a niche architecture, the HP blade system, and what it took to make blades a fairly common architecture, change-ready architecture in the enterprise today, was for us to build out what we call the Solution Builder program. We started out with 10 partners, and last I checked there were over 300 that really enabled blades to become less of an idea in someone's mind that has some promise and more of a reality today. So same practice that HP used in uniting with other industry leaders there in blades we're applying here. We're very excited about the Pathfinder program. There'll be definitely more partners that will be invited to participate at announcement and immediately beyond. Let's shift a little bit. We've covered what are the key announcement elements. Again, this is a journey. On November 1st, the journey begins where we're unveiling the architecture, why we're doing it, the enablement programs and platforms that will be built on over time. Will be open for with our website for customers to apply for access to our labs. We'll be extending additional invitations to potential Pathfinder programs. We're really excited about that. In the first half of 2012, as I mentioned before, the Redstone development platform will become available in limited quantities to select customers. There will be follow-on products, both development and broadly available products that we're not prepared to get into at this point, with a solid roadmap of innovation to follow. And as I mentioned, the Discovery Lab will open physically in Houston with worldwide access remotely, but we'll be adding both our European facility in Grenoble as well as a facility in China in the first half of next year. And we'll inform the market and you as analysts along the way as all of these, as the architecture matures, as Pathfinder program members are added, as best practices are published, and as additional lab facilities are open. Let's shift a little bit now, because some of you might be asking, why HP? Why now? How is this different? We believe it's very different, and we believe that what we're doing is forward-looking, it's innovative, and it's unifying the industry to, again, unlock the promise of these extreme low energy servers. Why HP? We have a pedigree of leadership in helping the industry move through transitions to capitalize on opportunities that end up delivering customers breakthrough value. If you go back to the mid-90s, people were arguing, well, will x86 ever really encroach on RISC and CISC architectures? Well, guess what? HP, working with industry leaders, creating value with customers, helped manage that transition where now x86 industry standard servers are the workhorses of all data centers today, period. And HP has been in the lead and been fortunate to glean the rewards of that work with 61 quarters of market leadership straight. If you look at, as we turned the century in the last decade, blades became a phenomenon. Virtualization became a phenomenon. Virtualization-aware networking became a potential way for customers to reclaim budget, time, space, and power and put that towards innovation. And HP led the way there with blades, with Virtual Connect, and over 5 million ports shipped. With today, how we're shipping cloud system, an app system, and Vert system with push-button simplicity for fairly complex solutions where people can be up and running in a matter of minutes as opposed to months. The last transition that we're starting to cross the chasm from early adopters to mainstream adoption was modular data centers. We've been proud to be at the forefront of leadership there. as I mentioned earlier, just in the last June, announcing the world's most efficient data center, where if you need the best performance per watt and most energy efficient servers, guess what? ProLiant SL is your choice. If you need to get a PUE of 1.05 in your data center, guess what? We can deliver to you in 12 weeks. It's called the EcoPod. Now, today starts the race for this next industry inflection point. This is not the checkered flag and the end of the race. It's the start of the race, the green flag of how are we going to be able to do the same thing in forward-looking innovation, enabling customers to have a guided path through this journey, uniting industry leaders large and small to have an architecture that's going to unlock the promise that these new extreme low energy servers hold. They are phenomenal savings, and HP is committed to doing just like it's done in the past, rallying the industry to deliver incredible value to customers so that they can reclaim budget, reclaim space, reclaim time, reclaim power, and shift that over to innovation and business value. That's why we believe HP is uniquely positioned, why our more forward-looking approach, much more than just introducing an ARM server, is necessary to make this transition, and it's also the obligation of the world's leader in industry standard servers. Going to, again, recap just really quickly. 4 things that we're announcing. One is at the core is the Moonshot architecture. 3 lanes of the highway to get the industry and our customers where this makes sense to that end destination of incredible savings in power, space, and costs. First, the architecture itself, moving from tens of servers sharing nothing to thousands of servers in a rack, virtually sharing everything. And then the 3 legs, the first of more to come in the Redstone development platform, the breakthrough industry first discovery lab specifically devoted to these technologies, and then the start of a comprehensive ecosystem of industry partners, large and small. Look forward to your additional feedback on November 1st. Look forward to keeping you up to date as we progress through this journey. We believe it's very exciting, and we will talk to you soon as things develop. Thank you very much. Sandy, you want to close it?
Thanks very much, Glenn and Gerald. Great job. So thank you again for your time today. If you have any questions or comments or feedback, please contact me at Sandra_Leong@hp.com. Thanks again. Goodbye.